Hello everyone. Welcome. Can you hear me? Hello. Hello.
Yes, hello. Yes, hello,
Okay. Okay.
Mr.
It's
Rahman.
okay.
How are you? I'm fine.
Walaikum assalam. Alhamdulillah. I'm fine. Hope all of are well. Okay. So basically, today I will try to discuss about the second class of land use land cover classification as well as the change detection. How you can easily make the change detection in Google Earth Engine platform and also calculated the transition area such as how much build up area, how much vegetation area convert into the build up area, how much barren land convert into the build up area, such as how much water body convert into the vegetation. Okay, so this type of transition zone, how we can easily calculate it. Okay, we also try to discuss about that, as well as I also try to show you this part how we can easily calculate the hello hello. Okay, some networking issue I think. So now can you hear me? Yeah. Okay. Okay.
Yeah, yeah,
Okay.
sir. Yeah, yeah.
Okay, thank you. Okay, okay. Okay, so let's go. Okay, so let's go. I simply share my screen. So now can you see my screen? Yeah.
Yeah,
Yeah. Let's go. Okay, so basically, this is the our seventh number of class, but I will take the air quality monitoring class the only one day, another time. Okay. Today, this is our second day of the land use land cover classification. And previous day, I also try to show you some basic things of the land use land cover classification, as well as also make the classification, and then we also try to calculate it the area for the small region such as Dhaka city. Then we can calculate the area using chart method. We created the chart, and each chart is represented the different classes area. Okay, but all time you did not make the chart. Okay, the chart is not when it across the limit of 5,000 element pixel value of your region, then the chart is not work. Then we need to apply the another method. Okay, so today I also try to discuss about the all of the method which you can easily calculate it the area for any big region or a small region. Okay, then we also try to discuss about the change detection. Okay, so let's go. So in this time, I just simply open my code editor and then try to show you the practically all of the things. So in this time, I want to work with the land use land cover classification map for the whole country boundary of Bangladesh. So just I simply import the Bangladesh country boundary shape file. I just simply show the layer. I put the name such as ROI, and then I simply show the layer. I simply use here the map.add layer function, and then call the ROI. This is my object name, and I also want to just center of this focus of this shape file. I simply use here the ROI. This is my object name, and zoom level 10 and click run. So now you can see I can get the country boundary of Bangladesh. This country boundary, I want to just make the land use land cover classification map, and then try to calculate it all of the classes for area. So in this time, here you can say I simply import my region of interest on Bangladesh. So in this time, I just use here the Modis dataset, Modis land use land cover dataset, global land cover dataset, and then I simply clip this dataset for my region, then make the land use land cover classification map from the Modis. So just I simply click on the browse data catalog, and then find out my dataset from the Modis. Okay, so now you can see I just simply find out the dataset for land use land cover dataset from the dataset is that okay. Yearly global 500 and try to filter this dataset for my region. Okay, so mainly in this time here you can see all of the information about your dataset. You can get the dataset between this time period. This dataset is the artisan snippet dataset provider. We can say the resolution 500 meter. We can get all of the dataset information. Also, you can see user guide algorithm. Also, general documentation. You can get all of the information from this link, as well as also the band. So basically, you can see this one band is LC type 1. This LC type 1, this band provided the IGBP. It means that annual international geosphere and biosphere program classification. Okay, so LC type 1, this band provide this classification, annual international geosphere biosphere program, this classification. Also you can see LC type 2, this is the another classification. So we can see this, it's called the UMD classification or University of the Maryland classification. Also you can see LC type 3, it's also provided the annual lived area index classification. In this time, under all of this band, we can get also some classes, such as you can see LC type 1. Here I can get total 17 classes from 1 to 7. So here you can see value 1, it represented the evergreen needleaf forest. Value 2, evergreen broadleaf forest. 3, deciduous needleaf forest. 4, deciduous broadleaf forest. So here I can get all of, you can see mixed forest, close shrubland, open shrubland, woody savanna, grassland. So all of the value identify different types of feature on the surface. Such as you can see 13, it urban and build up land. 12, it's only for the cropland. 16, barren land. 17, you can see the water bodies. Okay. So in this time, I want to use here the LC type 1, this band, and then try to classify it, all of the classes which are already available. Okay. Okay, so let's go. So first of all, I simply copy this art engine snippet from here. Just simply copy and then simply paste in my code editor. So this is my code editor. I simply paste in here. So I simply paste and then I simply put a variable name such as, I put the variable name such as, suppose you can use, I simply use the modis LULC. Okay, so LC. So now you can see my full image collection is stored in this variable modis LULC. In this time, this image collection I need to filter according to the my specific time period, according to my region, according to the band. Okay. So in this time, first of all, I just simply take a variable. Suppose I simply put the variable name, suppose filtered. You can use any variable name. Okay. In this variable, I add all of the filter option which I filtered. So first of all, I filtered the image specific time period. I just simply copy this and paste here. And then I simply use here the filtered date. Suppose I want to filter the specific time period. Suppose I want to make land use land cover classification map for year of 2000. Suppose 17 or 21 like this. So I simply use, okay, 21 dataset is not available. So you can see this is the dataset 2020. Okay. So just I simply take the time period 2017, suppose December 31. Okay. So I simply time period between this time period. After this, I select the time period. Then I also need to select this image specific band. Okay. So just I simply use here the select function. Select function. Okay, just a minute. I simply connect with my charger with my laptop. Just a minute. So okay, done. So in this time, you can see I also need to select this band. So in this time, I want to work with this band. This band is that LC type 1. I want to work with this band. I simply copy this band and then simply paste in here. So simply paste in here. So I simply filter my date and also select my specific band. Okay. After this, I just simply use here. I just simply try to show this map in here. So for this, I just simply use here the map dot add layer, and then I simply call the filtered and paste here and click to the run. Then you can check what happened. Another layer will be added. Okay. We can get this image tracer look like this totally black color. In this time, I also need to add here the visualization. So they are already added the some visualization we can easily get from here. You can see they're already provide You can see total. This is the IGB classification visualization. So I simply copy this visualization code from here and then simply paste in my code editor. Then simply copy this variable name, visualization variable name, and then paste in my code editor after the object name and click to the run. So now we can add all of the things. So it represented the whole world land use land cover classification between this time period. Okay, you can see we can get the whole world. Okay, you can see we can get the whole world land use land cover classification, all of the classes from 1 to 7, all of the classes, and we can get all of the description for all of the classes from here. Yeah. So now in this time I don't need for the whole world, I need only for this country boundary of Bangladesh. Okay, so that's why I already imported the shapefile of country boundary of Bangladesh. In this time just I simply take the another variable. Suppose I simply put the variable name, suppose Bangladesh LULC. You can put any variable name. Okay, then simply call this and paste here and simply clip with my shapefile. My shapefile variable name is that, you can say, ry. I simply use the ry. So now this is my final object. I simply copy this variable name and paste here. So now I want to get the result only for the Bangladesh area. Okay. It's showing that filter.clip is not function because in this time I want to use here this, I want to define it ee dot miss, then simply clip with this and you can check. Okay. Annual type image collection. So in this time, okay. In this time, I also need to reduce this image collection. For reducing this image collection, without reducing, you did not make the clip. Okay. So for this, I simply call this filtered, and then I simply paste here. I simply take here the annual mean from this dataset, and then I simply clip it. Clip with my shapefile is that ROI, and click to the run. We can check. Now okay, so now it will work. So now I can get the result only for the Bangladesh. Okay, let's see. So in this time you can see I can easily get this all of the classified area classes from the Modis dataset. In this time from this classified images you can easily calculate it all of the classes area at the same time. If you want, you can also take only for the single class calculated, same process. Okay, and this process you can also apply for the supervised classification also. So I also try to show you this part in here when I want to talk about the supervised classification map, and then calculated the transition zone. Then I also try to discuss about this part. In this time, I want to suppose in this time you want to from this classification map you want to extract only for the urban map or only for the extract the water map. It's very easy. Just you can simply take a variable. Suppose I simply take the variable name. Suppose urban. Okay. After urban, I simply call this Bangladesh LULC because this is the image. It stored all of the classes in Bangladesh LULC. I simply copy and paste here. I simply okay. I simply copy this. Simply copy and paste here, and I simply use the equal. So what's equal what? In this time, I select the value for urban. So what is the value for urban? You can see for the urban value is that urban and build up area. This value is the 13. Just I simply copy the 13 and paste here. Okay, so now you can see I can simply show this result map dot add layer, and then I simply call this urban. Okay, and I also want to the visualization. I simply use the mean 0 and max. I simply put the 1, and then use the related functions such as I make the list where there is the no urban. I want to show this is the gray color, and where this is the urban, I want to show this place is the red color, and click to the run. So now I can check, I can get only for the urban feature from this for the Bangladesh. Okay. So now we can get, you can see only for the red pixel value, it's identify only for the urban area map of Bangladesh, whole country boundary of Bangladesh. Suppose in this time you want to just calculate the urban area map of this region of Bangladesh, we can easily do it. So for this, in this time I just calculate only for the urban map from here. Okay, how much urban area is available for the whole country boundary of Bangladesh. Or suppose you want to calculate the suppose agricultural land, just you can simply get the agriculture, you can see cropland. Okay, so just you can simply change this, suppose simply copy the 12 and then simply paste in your in here 12. So this is the value for the cropland, and to show the cropland as a yellow color, you can simply change the color yellow and click to the run. So now I can get only for the area for the yellow color area, it represented only for the cropland, only for the cropland map we can get. Okay, you can see now all of the cropland it's showing only for the cropland area in Bangladesh. Okay. In this time, suppose you want to calculate the area only for the cropland, how much cropland is available in here for the whole country boundary of Bangladesh, or how much build up area, just you can change, then you can easily get the result. So in this time, I calculated the area, total cropland area, how much cropland area is available in this image. I want to calculate this. So mainly when you want to calculate this, we need to use a function. It's called the eimage.pixel area. So we are using this function eimage.pixel area. So before using this function, I just take a variable. I simply take the variable. Suppose I put the variable name is that suppose area image. You can use any variable name. After this, I simply call the urban because I want to calculate the urban. Sorry, this is the cropland. I simply change the name. I use the relevant name crop. Then it also better. I simply relevant name. You can use any variable name. There is no problem. Okay. Any question? Yeah, please. Yeah. Anyone? Any question? Any question?
Yes.
Yeah,
Okay, okay.
please.
Continue.
Sir, like you're working on Modi's data. Can you show us, from the start on the Sentinel images, like how classify the image, and then from there how to extract the areas and the change of areas between temporal changes.
Okay. So there is no problem. There is a lot of project work, lot of code we already done. So you can see in this time I use the modis as well as I also try to show you the different time period images for the Landsat, and we already work for the Sentinel. So all of the project I also try reveal after step by step. Okay, then it also better. And for the calculating, which I want to show the process in the modis, same process also for the Landsat, same process also for the Sentinel. Just we need to change the scale of the modis. What is the scale of the modis? This scale is a 500 meter. When you want to use the Sentinel, this is the 10 meter or 12 meter. Landsat for the 30 meter. Just we can change, but calculating the process, all of the land use land cover classification changes or calculated the transition zone, all of the time same code, same things, all of the things will be same all time. Okay, just we need to change the band pixel band resolution, this value we can change, but otherwise all of the things will be same. Which image you want to use, it doesn't matter. Okay, but I also try to share you the some project work which I already work, then you can easily understand. Okay. Anyone in question?
Yes, Assalamu alaikum.
Walaikum assalam.
Rahman, I just have
Yeah.
one question. Like, this shapefile is for whole Bangladesh. If I want to calculate this land use or some other stuff, I'll be using like some district wise. So if I have, let's say, all district in one shapefile, I want to have each district in like the percentage or something like that. So is that part will be covered here? I
So
want
in
to
this,
have district information.
okay, district wise, then you have to just change the shape file. You have to import the district shape file, and then you also need to filter this shape file. Okay,
Okay.
And you can see this is the district shapefile. Suppose you want
Yes.
to need the first of all you need to import the shapefile. And first class, I think first class I also try to show you this part, how you can filter the attribute table and get only for the specific area. Okay.
Okay.
Suppose in this time, I already show this part. You can see I simply import this
I
table.
mean, I'm
Yeah.
if I use this shapefile Bangladesh district, okay, and I want to have all district information in in an Excel file or something like how much build up area is there, how much urban area is there, something like that. I mean to say district wise with district name and this percentage is for urban. This is for like that. I mean to say.
Okay. So you
In
want to do for the step by step. Okay. Suppose you want to take the code. Just you need to add the code for the wrong different district. You need to add same code.
uh-huh.
Okay.
Okay.
Suppose in this time I write the I just simply change my area. The same code I simply take this result for, suppose I simply take the variable, suppose district, suppose Dhaka district. I work with the Dhaka district first. I simply filter my district, filter equal to, I simply put here the, I check my attribute table again. I simply work with the name one. This is my column name, and I simply put here this name and then just use here this Dhaka. Okay. And then in this time I want to work only for the Dhaka. So I simply copy that Dhaka and I simply click with Dhaka. I simply click with the Dhaka. Okay. And then all of the things will be same. Just I simply click to the run. So now I work with only for the Dhaka district. You can see I get the result only for the Dhaka district. Okay. So now you can just calculate all of the things for the Dhaka district. Then you can get the percentage, how many. Then you just simply change the name, suppose. So this is the Dhaka district. We can get this map look like this. Okay. For the only for the Dhaka district land use land cover classification, you can get. Okay. So I think it's showing the Dhaka division. Just a minute. I simply change that. This I think it will be 3, name 3, and then click to the run. So now we can get only for the Dhaka district or division. So take the shape file again. So it's just the name 2. Sorry, name 2. Name 2, it's showing all of the district. Okay. I simply name 2. Here. So now it works. Okay. So now you can say I can get this result for the only for this Dhaka. And you can see for the Dhaka city, mainly this part from the Dhaka city, there is the very there is the not much of cropland, but other district periphery of the Dhaka city we can get the some cropland. So you can just change the name. Suppose I want to work with for the Rangpur district. I simply use here the Rangpur and click to the run. So now I can get the result for the Rangpur district. Okay. So you can see I simply, you can say I can get the result for the Rangpur district of this land use land cover classification. And now it also showing the map for the it's showing the for the agriculture, because you can see I want to add here the cropland. So now this is the another line is showing the cropland, and this is my classification result.
Yes,
Okay.
Rahman.
Yeah.
Yes, I have got the point. I mean, like this, for example, this district has this much crop land. Okay, this much.
Okay,
Let's say
so
30.
first up, let me finish my calculation part. Then you can. I hope you can understand. Okay, so I did not finish the
Okay.
calculation part yet. So when I complete the calculation part, then you can easily understand about this topic. Okay. So in this time, I just showing you that. Okay, step by step. Okay. Anyone in question? Yeah, please.
Can we download that
Yeah.
shape files of cropland separately, upland separately, and we can utilize it in the objects also as a layers?
Yeah, we can also do it. Yeah. Suppose you want to just simply export this map as a TIFF format for the cropland as well as a build up a water body, then you can also work with the map you can easily show the map. Yeah, any question?
Then we have to
anyone?
do raster to vector layer
Yeah,
like that.
yes.
After that, we can do, na?
You can get the raster to vector layer as well as ArcMap software. You can also do for the Google Earth Engine platform also.
Okay.
Okay, please.
Yeah,
Any,
yes, please.
yeah.
Yes, please, Mr. Rahman. In our code, we have the filter syntax. If you in your code editor, in case, yeah, now we are filtering in Bangladesh, for example, using the name of this Dhaka or whatever. In case we have two districts in our study area, يعني existing two districts, but the argument of filter just take only two argument, name plus the name.
Yeah.
Got my point?
Yeah.
So in case we have two district, how we can filter it? We have to write
Okay.
two
Okay.
line
Then
of
you
code,
need to take
or
the
just
another variable, and then put here the another district name. Okay, so I'll also try to show you this part. Suppose in this time I need the result also for the another district. Okay, so for this I just simply
exactly.
copy this code. I simply copy. I just simply paste here. Suppose I simply put this name. Suppose another district. Suppose I put here this Kurigram. Okay. Then I simply change the district name. Suppose Kurigram. Okay. In this time, I need the two layer Dhaka and Kurigram land use land cover classification map. In this time, you can see I already work with the Bangladesh in this variable. I put this. I also copy the same code also. I simply copy and paste here. I simply put this name. Suppose in this time, I simply put this name. Suppose Kurigram LULC. Okay. In this time, I just click with this Kurigram shape file. And Kurigram shape file is I simply copy this variable name from here and then simply paste here instead of the Dhaka. Okay. In this time, you can see what happened. I simply copy the same code map.add layer again and paste here also. I simply call this object and paste here in here. Okay. So now you can see when I click to the run, I can get the another layer in my layer. In this time, I can get the another layer. And it now showing here the two district land use land cover classification map at the same time. Rangpur and Kurigram. We can get this result. Okay.
Excellent. In case we want to export it, it will export two image, or could we make it in one image?
So it's totally different image. You can see another layer. So you can see layer 4. Okay, you can see we can get this two district, but these two images are totally different. It's not the combine. Okay, so you can separate. You can see this is the one for the Kurigram LULC, and this is the one for Rangpur district. So they are the two totally separate area.
Okay. How we can export it in one map? يعني in case our study area exists in those two layer. Do we have any way to export it in one map?
Okay, we can do it. We can do it. Suppose in this time you can see it's totally separate shape file Dhaka and Kurigram. They are the two districts. You first of all you have to make the merge between Dhaka and Kurigram. Then it will be at the same time it will be work. Okay. Suppose in this time, this is the I will simply create the shape file look like this. You can see I just simply take the variable. Suppose this is I simply take the variable name. Suppose final region. Okay. Then I simply call the Dhaka and paste here. It merge with suppose Kurigram. Okay. So Dhaka and Kurigram. Okay. If you want to check the boundary for the final region, you can check it from here, map.add layer, and call the final region. In this time, the two boundary of Dhaka of this two boundary is the combined. You can see. Mainly, you can see it showing the Dhaka. Variable name can be anything. There is no problem. But what's the value in stored in here? In this time, it is storing the Rangpur. Okay. So now it will be showing the Rangpur. Okay. So variable name can be anything. there is no problem. I simply click the run. You can see in this time I can get the another layer. This layer is the combine the two district. You can see. I simply remove. Okay, you can see in this time this layer which I want to add in here, final region, I just merge these two district. I merge. Okay, so now it look like a one shape file. Okay, when I want to simply
Yeah,
copy the final region, this region clip with my shape file, just I simply clip. Suppose I simply clip and click to the run. In this time, when I want to export this final region, it will be export at the same time the two district.
excellent. Yeah, this is what
Yeah.
this is my question. Right. Thank you.
Yeah. Okay.
Any open sets like LULC data for land use land cover of Sentinel data using or Landsat data using like Modis?
Okay. So in this time, Modis is using the suppose when you want to Sentinel. Sentinel is also another data set for the ready-made data set. See, when you want to go to the Sentinel, they are also provide the ready-made data set also. You can see dynamic world, land cover, as well as also history, land cover, land use classification data. It also provided by Sentinel. Check it. You can see this data set, dynamic world, history, world cover data set. Okay, this two type of data set, we can get it from here, from the data set totally ready made. And when you want to work with the data set, the same process. When I want to show the modis, also you can see when I click on the this data set, you can get also some band. You can see I simply open this data set. You can see this is the artisan snippet from here data set. This data set has a band. This band name is the map. Okay, this data set also some value. We can see value 10 identify the tree cover, value 20 identify the subland, value 30 identify the grassland, 40 cropland, build up area band, snow ice. So it also another data set, and this data set provide you the sentinel. Okay, it combination of based on the sentinel 1 and sentinel 2 data. Okay, and 10-meter resolution. Okay, so you can also try to for your own self for getting the data set and calculating the area, the same process which I want to show in this time. The same process you can also apply for the sentinel, this data set. Okay, and this data set is the high resolution because this is the 10-meter resolution only. We can get all of the feature very we can get the accurately all of the feature very quickly. We can get accurately and efficiently. We can get in this time. You can see when you want to use the data, the same process. So I also provide you some assignment or homework on this data set. So you also try to for your own self for making the any area you can calculate the area of all of the classes. You can calculate the area which I process I want to show in this time. Okay. Okay. So in this time, anyone in question? Any question? Okay. Okay. So in this time we talk about this part. I simply work with the big region because a small region we already covered. But a small region also same process you can apply. There is no problem. Okay, you can see I want to just show the whole country boundary of Bangladesh for the cropland. So now I just calculated the area. Okay, for the cropland for the whole Bangladesh, how much cropland is available, how much area is available for the cropland. Okay, so mainly when you want to calculate the area, we are using a function. I simply take a variable, then use the function. So I simply take the variable, suppose area image, area image. In this variable, I want to calculate the crop land. I simply copy the crop and I just simply use here the multiply with a function. This function is that okay. So okay, it's not possible in this time because there is a lot of code. If you want to need the code, you can just text me. I will show you that. Send you. Just you can simply copy and paste and work with this. There is no problem. And you can also get this from the ArcMap software. For you can easily search in here. You can see. Simply search here raster to vector. Then you can get the data. Simply import the vector that tip image or raster image. You can easily vector. Okay, you can see raster to vector. Simply search here. You can see raster to polygon. So mean it's conversation tool. So when I simply click on here, then I just simply import my tip image. So input raster image you can put. Then you can simply your field you can simply put. Then you can simply put the output file polygon feature. Then simply okay. Then it easily convert to the raster to the polygon. It means that raster to vector. Okay. So I also try to show you this part when I want to work with the change detection map. Okay. Suppose in this time when I want to make the change detection map, then using the ArcMap software. Okay, this class I will not showing today, but in a last class I also try to add this part for the change detection map. Okay, in this time we can calculate the change detection only using the Google Earth Engine platform. But when you want to perform the change detection map, we need to use here the ArcMap software also. Okay, then we also try to show you this part. Okay, so in this time, let's go our class. Okay, I simply multiply with a function. This function called, you can see this function is that e dot image dot pixel area. This is the function. When you want to calculate the area from the raster image, we need to use the function e dot image dot pixel area. So basically, this function you can get the result in square meter. Okay, in the pixel area you can get square meter. So in this time I simply call my crop because it stored the crop land of Bangladesh. I want to calculate the area, so that's why I simply call this function. I simply write the function multiply with this function e dot image dot pixel area. Okay, so in this time I simply multiply with this function and it calculated the area. Okay, so when you want to calculate the area, how much pixel area is available for the cropland, I want to calculate this, then I need to use a function, this function called the reduce region. So I simply take a variable and give the variable name is that suppose area. Okay, then I simply call this area image. I simply copy and paste here area image. I simply paste here. Then I need to use a function reduce region. Okay, so mainly when you want to calculate the area, suppose you want to calculate the average result, you want to calculate the minimum result, you want to calculate the total area, then we need to use the reduce region function. And you can get all of the argument for the reduce region. You can see I simply make a dictionary in here. So I simply use the curly bracket start. Curly bracket start. So can you hear me? Hello, can you hear
Yes,
me?
bro.
Okay, some networking issue. Okay, just a minute. I simply take my phone. I have an important phone. Just simply take and then continue. Just okay. So now, okay. Okay, so let's go. Okay, so now we can continue again. So in this time, you can see I just simply use at the e reducer dot sum because I want to calculate the total area. Then geometry. So geometry, I simply use here the what is the geometry? Geometry is that my region, and region is the Bangladesh shapefile. Bangladesh shapefile is stored at the variable ROI. I simply use here the ROI. Then scale. What is the scale? Scale is the resolution of your satellite images. It says as 500 meter. Okay. Then in this time, I simply I simply all of the things. Okay. Then I simply just print this. I simply print I simply print this. So use the print function, and then call the area and paste and click to the run. So now I can see it calculating, computing the area, total area of the cropland. Okay, I simply click here. You can see I can get the result in square meter. Suppose I want to change the unit. Suppose I want to need the result in square kilometer. So for the conversion, I can simply divide it with the 1 million or 1 into 10 to the power 6. Then it convert the result in square kilometer. So for this result, when you want to need the result square kilometer, just I can simply take the another variable. Suppose area square kilometer. In this time, this number I want to convert, and this number is stored at the variable area. Okay, just I simply use here the ee dot number, and then I simply call this area. Okay? I simply call this area, and this area where I can get this area I want to get from a band. Okay, you can see in this time LC type 1, this band, from this band I want to get the area 13. Okay, you can see LC type 1 all of the class under the LC type 1 band, all of the class. So I want to get this class from this band, so I also need to define it. So for this I simply use here the area get, where I can get from this band LC type 1. Okay, so in this time I just simply divide. So I simply divide it. So I simply divide it. 1 is 6. Okay, so now it just I can simply 1 is 6. When I simply print this, we can get the result in square kilometer. I print this area. I simply copy and paste here and click to the run. So now I can see I can get the result in square kilometer. How much area? In this time you can see I can get the sum holding so I simply use the only for the integer. I simply use here the round function. So round. Suppose round, click them. In this time I can get only for the integer value. Okay, how much cropland area is available for the whole country boundary of Bangladesh, we can get this result in here. Okay, suppose in this time you want to get the how much build up area, you can simply change the value 13. Okay, then click to the run. So now it's showing the result for the how much build up area is available for in here. It's also showing the only for the build up area. In this time build up area showing as a yellow color because I use here the yellow color. You can use any color. I can get total area. Any suppose the water bodies, you can check the what is the water bodies value. You can see the water bodies values is that water bodies is that 17. So just I simply put the value for this in here 17, and then I want to water body, I want to show as a blue color. So I simply use here the blue and then click to the run. So now it's showing the all of the water bodies. You can get total water bodies area. So now you can see it only showing the water bodies, and also it calculated the total water bodies area. In this is the square kilometer result, and this is the square meter result. It's a square kilometer. Okay, you can get this. And when you want to export this map, you can use the same process. Just use the function export image to drive and put all of the argument. Then you can easily export it and work with the ArcMap software for making the map or other things. Okay. Okay. So this is the process when you want to work with the single class, such as only for the water, only for the cropland, only for the barren land. This type of class when you want to calculate it. But when you want to work with the group number of class, in this time you can see this is my all of the classified area. Okay, it can be water, forest, deep forest, all of the class is available for this image. When you want to work with for the all of the classes at the same time, you want to calculate all of the class. Okay, okay. So for this we can also use the another function. We need to make the group. Okay, when you want to calculate all of the class, total 17 class is available for this data set. We need to make the group all of the 17 classes and then calculate the area. Okay, so in this time I show you that only for the single class how you can easily calculate the area, but from this the classification all of the class is available. In this time we calculate the area all of the classes at the same time. Okay, so let's go. So for this, when you want to calculate the all of the classes from this image, we need to use a function. Same function we can need to use. So I simply take a variable. Suppose I simply put the variable name is that area image. You can use any variable name. I simply put the area image. Okay. After this, I simply call my function eImage.pixel area. Okay. So this is the function, and this function return the result as a unit is the square meter. I simply paste here. Okay. In this time, I want to call my classified image variable name. This is the image. This image is stored in a variable. What is the variable name? You can check the variable name, the Bangladesh LULC. I simply copy and then I simply use here add bands and then paste this classified image name in here. Okay. So in this time, this variable is stored this classified image. Okay, I want to add this band with my function. Mainly this function get the result in square meter. Okay, so let's go. In this time I use the same function, such as I simply take a variable and give the variable name is the any variable areas. Okay, then I simply call the area image and paste here, and I simply use the function reduce region. Okay, reduce region, and then I put all of the argument in here. In this time, when I fill up this, then I can easily get the result all of the classes at the same time.